In this video I will show how to connect the AA batteries to the buses on the breadboard. We have solder tabs here, here. So this positive side of the battery, of this battery, we'll just take a red wire, bring it to this bus. Negative side of that battery we'll solder to this tab. We'll take that wire nice and neatly up through this channel. That way it's out of our way. We won't bump into it, accidentally snag it and knock it out of place, which can happen when you're breadboarding, busy doing other stuff. So we'll bring that nice and neat up here. It's a long wire, but it'll be out of sight and hidden in there, and we'll bring it right to this negative bus. That'll be this battery. We'll have these two buses. And then likewise we'll take this battery and we'll take a red wire, solder it to that tab, run it down this channel nice and securely, and then to this bus right here, and then we'll take the negative side of this battery and bring it right over to this bus right here. So it's simple, not all that complicated, but it will also serve as a nice introduction to soldering. If some of you haven't soldered before, this is a nice easy step into the world of soldering. So we'll be soldering the wires onto these tabs and showing you some techniques there. Now the very first thing we have to do is remove the batteries. That's important, because if you've ever tried to solder a battery terminal with the battery in place, you'll found out it acts as a very large heat sink. So the battery would be heat sinking heat away from this terminal, and it's hard to get the solder to flow. It's hard to get enough heat on that terminal. So the heat sink we have to remove, which is the battery. It'll also be heating up the battery. You might have if you've ever tried to solder a wire directly onto a battery, same problem. I remember as a kid trying to do that, not having much luck. So the batteries have to come out, and that leaves us with a solder terminal that we can solder to without too much trouble. I think a good thing to do is probably bend these tabs out a little bit. That just gives us a little bit more separation between this tab and the body here, where we wouldn't want to accidentally be touching. So I mean, that I think is a good idea. Just flare them out a little bit, and then maybe another thing might be just to bend them over a little bit. I think that's probably nice. They just don't have to be sticking up so high, so it'll just reduce the height of our assembly a little bit, profile. And we could even take them all the way over. You know, these are just the little things that make life nice later on. I don't know how far to take them. Could go the whole way horizontal even, maybe. Okay, so I think I like that. Flared out, and you see what I have now. I have less likelihood of anything that I do here, because I'll be adding solder, and it'll maybe add to the thickness a bit. I don't want that to get close to this. I've seen that happen where people are a little sloppy and their wires are touching the case here and shorting out. So I think that looks good. The first rule of soldering is you have to start with clean surfaces. So any oxidation will make it difficult for the solder to wet to. So you can use a little bit of Scotch-Brite or something. Just make sure you get all the oxidation off. And now these don't look too bad. I mean, they look, but you know, bright and shiny is really what you need. So when in doubt, it doesn't hurt to buff it up with a little bit of Scotch-Brite. Not steel wool. Can you think why? Steel wool will just leave all kinds of little pieces of steel wool behind, and you will have a real likelihood of shorting things out with that. So little strands of steel wool all over the place. It's metal, and it's a horrible idea, and that can really wreak havoc on things. So never use steel wool to buff things out. Sandpaper's okay. The grit, the sand gets everywhere, so maybe that's not even as nice. And this does a better job of buffing. So yeah, so a little bit of Scotch-Brite. I think we got some clean surfaces there. If our copper wire was looking dull, we can always shine that up too. But usually, unless you have something that's been laying around too long, usually that's not a problem. So, but take a look. Make sure the copper's nice and shiny too. And you know, that's exactly the same thing a plumber would be doing. You know, if you've ever soldered copper piping, first thing you got to do is shine it up. The soldering iron that comes with your toolkit, I think it comes fitted with something like a chisel tip like this, which will actually be good for maybe this kind of work. It's a heavier mass tip, and that just helps you with the amount of heat you have ready to go when you apply it, to your workpiece. This is actually not the identical tip. I couldn't find mine. I've had on my iron, it's the same iron. I want to try to use the same one you have in your toolkit, but I've fitted it with a conical tip. It also has decent mass for this kind of work, so I'll be using that. But you'll probably leave leave the chisel tip that comes with your iron. Leave that in for this exercise. You've also got in your toolkit for fine PC board work. You've got a very sharp conical tip, so that'll come in handy for fine work on like a PC board when you're soldering components on a PC board. Don't put the sharp conical tip on. Leave the chisel tip on. In my case, for this example, you'll see me using the conical tip that's maybe not quite so sharp. But I'll be using that. But yeah, for yourself, that chisel tip should work. And the iron you have in your toolkit is the Electronic 258. It's a nice low cost, low space consuming iron that you just carry around for simple work. It does have this temperature adjustability here, so for soldering terminals like this, I'm gonna turn it all the way up and see how I like it. I can cut it back if it feels like it's more than I need. If you're trying to gauge what temperature to set your iron at, it's always about sort of a 2-second rule. Your iron should be hot enough that you can heat up the workpiece, apply the solder, have the solder flow and wet to the surfaces smoothly, and all that should be accomplished in 2 seconds or less. If it's taking too long, if you have to hang out there too long with your iron, the iron temperature isn't hot enough. If it's a little out of control, if it seems to be just, happening way too fast and just burning things, for example, things getting way too hot, of course you can dial the temperature down. You don't want to use any more heat as far as what temperature you have your iron set for. You don't want to use any more than you have to get the job done in 1 or 2 seconds. So that's the general rule. Put the temperature setting as low as you can and still be in and out of the workpiece within a second or two. It's the general rule. So I don't know. I haven't used this iron much. I'm gonna start high, and if that seems a little excessive, I can always back it off. If I was soldering components onto a PC board, like an IC or something, I probably wouldn't be so aggressive. I would probably set this temperature maybe at the halfway point for starters and see how I like it. For PC board work, maybe that's where we'll use it. But like I said, I haven't used this much, so we'll sort of experiment and maybe find out what settings we like. Again, all surfaces need to be clean and shiny, and the soldering tip is no exception. To maintain a nice clean soldering iron tip, brass works great. You just can clean the tip easily with this. Brass is good because it's a softer metal. It's softer than the metal that the tip's made out of, so it won't scratch it. Don't ever use sandpaper. That quartz will just scratch it and degrade the tip. So you always want to make sure you have a brass sponge like this is one solution, or you might even have used, if you've soldered before, but a sponge, a wet sponge is another way to sort of shock the oxides off the tip of that iron. But yeah, the brass sponge is a nice choice. So you should have one of those in your toolkit, and that'll be a way we maintain the soldering iron tip. Okay, so I've plugged the iron in, and it's not a real expensive iron, so it's going to take some time to heat up. It takes a little patience. It's one of the things that, for the lower cost items, maybe that's the trade-off. Just takes a little more time to get them up to temperature. One thing you want to be ready with, though, is some solder, and what you usually do is, I think you have a little length of solder, maybe coil it up and just have it ready, a length of it here, If you have a whole spool, it's soft enough, solder is, that you can just tear off a piece. But you want to have it ready to go, because especially if it's the first time you've brought the iron tip up to temperature, if it's the first time, you need to have solder ready to flow on there to help tin the tip and keep it from oxidizing. So that's an important thing to remember, especially with a new purchase. So I have it plugged in, and I'll just sit here waiting for it to come up to temperature, but ready with the solder to coat the tip as soon as it does come up to temperature. All right. And generally, you do want to leave the tip coated if it's sitting in the iron in the stand, and while you put another part on or something. It's a good practice to leave a little solder on that tip, just to keep it, again, help preserve the life of the tip. So okay, so it's finally up to temperature. So I'm just running some solder around, and I want to make sure that I get it all on there and coated. Alright, so like I said, that's especially important if it's the first time you've turned the iron on with a new tip. Alright, so that's doing a good job of tinning it. Now I can just shake that off, whatever the excess is, I'll just shake that off. And then if I'm ready, I have a habit, when I'm ready to solder, I'll just clean the tip through the brass. So right now I'm just going to put the iron in the stand and get my other stuff ready. But when I'm ready to go, I'll give a swipe through the brass sponge to clean it off and take it to the workpiece. By the way, the surface that I'm using to do this work is just a silicon mat. You can get these on Amazon. Maybe they're like a foot by 10 inches or 10 by 12, something like that. I forget what I paid for it, maybe $10. Maybe you can get them for $5 or as high as $20. I've seen them, but yeah, it's just a silicon mat, so it's a it's a high temperature silicon that it doesn't matter if you get splashed with solder and so on. So that's a nice way to have a work area for soldering. Okay, so I'm going to take a piece of 22 gauge red wire, take it to the positive terminal. You can see I kind of looped it through. I'm coming through from the back side. I'm going to make the top side sort of where I apply the solder in the beginning. I want to get this looped, but you know what? I want to do a little bit of mechanical fastening here. It just makes life easier. It's important actually that the wire doesn't move while I'm soldering. You don't want the joint moving around. So really, what I'm trying to do here is get some mechanical fastness here to the workpiece that I'm trying to do. So I've looped it, and then I've kind of crushed that loop on the little eyelet there. I'm going to work top side first, and then I'll come around to the back side, make sure everything flowed. When you have the solder joint done, everything should look smooth and shiny. Things should be, a good joint would be concave, flared all the way out, nice and smooth, sort of like a smooth slope. And you'll see that when we get done. But there's some way to make it sort of mechanically fastened is helpful. Everybody has their methods. You don't have to do that. You can do a technique where you would apply solder, and make sure that it adhered to the terminal, and also tin the wire, and then lay the wire on, and fuse them together. So that's sort of a tinning fusing method. It doesn't have the structural strength that you have here, and it also is sort of a two-step process. But I guess there's many ways to do simple soldering for sure. This is one technique, so you might want to follow this if you're new, or if you have your own methods, that's okay. Oh, and another thing you can notice, I've looped it and crushed that loop on to sort of hold itself where I want it. But the other thing is I've tried to keep the insulation far enough away from the actual soldering I'm going to do, because I don't want that insulation melting and coming in and contaminating the joint. So you don't want it to be too sloppy where the insulation would be laying right up against the terminal, and you'll have melted plastic joining the flow with your melted solder. So you don't want that. Of course, you don't want it stripped so far that you have a bare wire that's out there to be bumped into or be shorted out. So, yeah. And another cheap but useful tool you have in your toolkit is just this thing called the helping hand. You can buy more elaborate ones, gooseneck varieties and so on, but you know, you just really need anything. Some people call it a third hand, and exactly what it is, right? So I'm using that to sort of hold my workpiece in a position that I want it for easy access to whatever I'm trying to solder. So you can assemble those and use those, and right, these are the poor man's variety of a third hand, but they work just fine. And then, like I say, you can get more elaborate ones too. Okay, so let's try to solder this joint. Both the workpiece looks nice and clean. Now, what I'm going to do is clean the soldering iron tip by just swiping it through the brass sponge, so it's nice and clean. And then I'm going to bring it in. Now, some people and I like to put a little solder on there sometimes, make sure my tip is looking good. It was getting a little rough as it was sitting in that area, and it, you know, boy, these irons are a little cheap. So we'll see how we like it. I mean, you know, you get what you pay for. All right. So one thing you're going to have to do is you lay the iron in against the workpiece, and then we're going to bridge a little bit for heat transfer, and I'll explain that in a minute. Let me see how I like this iron here, and then get out. Now this is taking a while, getting used to this iron. So let me see if I can bridge this. Wow, this is ugly. Okay. So that's something that worked, I guess. I think the heat might be a little high. I might knock this down. That felt a little out of control. I don't think I need the full. I'll dial it to 3/4 maybe. The tip looked a little black too, but I mean, that's part of what we get when you just get an iron like this. You know, a low-cost iron. Tip maintenance is going to be a little rough. Maybe a little less than 3/4. Tip just looks like it's blackening quickly. A couple things to point out. So I'd say we have it successfully soldered. Notice how smooth and shiny it is, and it should have, you know, covered everywhere. Couple of quick techniques, and we have a solder video for you too. So if you've never soldered before, maybe go into a little more detail. But notice when I came in, the first thing I did was called bridging. I mean, I might wet the tip a little bit, but then bridging actually is this action here, where you fill in any micro gaps between your iron tip and your workpiece just by letting molten solder do that, because what that does is it makes the heat transfer happen quickly between the workpiece. Now you move over here. I can tell that I have enough heat on the workpiece when solder is melting over here. It's exactly the same thing. A plumber soldering copper pipe. You know, he's not going to melt the solder with the flame of the torch. He's going to heat the copper pipe with the torch and let the pipe, when it gets up to the high enough temperature, let the copper pipe melt the solder. That's very important. It's the workpiece that needs to be up to temperature so that the solder will wick to it, flow to it, adhere to it, and so on. So, you know, that's a very, very key thing. Maybe we'll illustrate that some more. We can go around and do all 4 terminals, and I'll keep, you know, sort of talking about these techniques. But, you know, it's also, notice, I guess I held the iron still. I mean, you don't dab, you know, you don't try to apply heat by poking at the workpiece. The iron stays still. If there's any poking to be done, it's the application of the solder. You can move around the workpiece. You can feel that it's hot enough everywhere. It's really the feedback you're looking for as the solderer is the workpiece up to temperature? Is the solder flowing smoothly? And you can tell that as you move around the joint, maybe to different places with the solder. But the iron stays in one spot for the most part. And doesn't move. It's supposed to stay there, get hooked up with heat transfer by the bridging, which is applying the solder right at the place where the iron meets up with the workpiece. But then as soon as you get that bridging accomplished, where you can see the heat transfer happening, and you can tell because the solder starts to flow onto the workpiece, move away. Don't feed solder at that joint between your iron and the workpiece. Move away to someplace distant, and you can get a sense that your workpiece is up to temperature, and you'll know that the solder will adhere to it there. If you don't follow those techniques, you can get what's called a cold joint, where it looks like it might be done, but it might not have adhered very well, and it can crack or break off. I'll try to show you some of those, actually. I can do some bad joints on purpose. Let's flip it to the back side of this solder terminal. Okay, it looks good. I mean, it flowed everywhere. Notice why I flared out the terminal, right? Because, you know, if I hadn't done that, I'd be kind of getting awfully close to possibly shorting out. But again, the wood is smooth and shiny to know that it got hot enough that everything flowed, you know, and tapered down to a nice thin, so shiny. Yep. So it shouldn't be, you know, chunky or dull or you know, clumped up or balled up. Those are all signs that either the workpiece wasn't cleaned, you know, it wasn't clean enough, or it didn't get hot enough, and so on. So let's try a couple others, and let's see if I can even demonstrate some bad joints. We can try that. This iron, like I say, you know, it's more in the $20 range, so it's a little bit of a challenge to work with compared to an iron you pay $250 for. They actually make life really easy. They work so well. So, you know, the tip maintenance and stuff tends to be a little better. You don't have to constantly be fighting a tip that's overheating and getting black and tarnished. The temperature regulation is one of the features that you get with more expensive irons, and it does make your life easier, I'm not going to lie, when you're doing soldering. This one takes a little more of a watchful eye on that tip. It gets cruddy pretty fast. You have to keep cleaning it, and because it does tend to overheat itself when it's sitting still in the stand, and as opposed to when you bring it to the workpiece, then you start wicking some of that temperature away. So it's not the easiest iron to use, is the bottom line, but it's easy on the wallet. You might have noticed, for now I'm just letting the wires run wild. I just made sure I have plenty of length. Maybe I went a little crazy on that one. But I'm going to just solder them onto the tabs, and then I'll finesse the length and getting them into the breadboard. For now, I just wanted to concentrate on the actual soldering. So let's do the next tab. And again, I'm just going to cut a length of wire that I'm certain is long enough, right? So I'm just going to make sure it's long enough to get up through that channel, and then we'll solder that one in place. I'm going to use the same technique. It seemed to work well on the other one. I'm going to loop it through from the back and then bend it around, try to, you know, hold it in place just by sort of squeezing it with a needle nose. And there you can see I just kind of crushed it on there to hold itself. If you have a little excess of stripped wire, you can just use a flush cutter, as I did that, and just nipped it off a little bit. You want it to be all nice and neat, ready to go. If you can't even do that after you've soldered it. I mean, if you have little points sticking out, the solder's soft, you can cut right through it. Alright, I have my helping hand holding it sideways for me again, and I think I'll try to do another good joint before I show you some bad ones, just to sort of help reinforce that. So I've cleaned off my soldering iron tip. I have the temperature set a little less than 3/4. I'm going to just see how that temperature, how much I like that. So I'm going to bring the iron in. I'm going to wet the iron a little bit. Now I'm going to bridge, and now I'm going to feed, right? Make sure it's hot everywhere. Yep, and be done. That's a good example probably of minimal solder. I mean, it's plenty. I can leave it. I could add a little more, but I really don't have to. Maybe I can zoom in on that for you. So this joint is a good example of how well the solder can flow. I can see it got up to temperature. You know, it flowed very well, nice and flat. The surfaces were clean. I don't have to add more solder. I could if I wanted to, but there's no gaps. It all filled in nicely. Around the back, I can see that it flowed. You know, if I was worried about that, I would just apply heat to the back side too with the iron, make sure everything flowed. But yeah, but it's actually, it would be fine the way it is now. It's no problem. I can add a little more just to show you. So So if I needed to reflow, again, clean the tip off, start with nice and clean tip. It's a little dirty, so I'm going to apply some solder and clean it off. Okay, there we go. Again, I'm going to wet the tip, and then I'm going to come in here, bridge. Look how fast it happens, though, because there was already solder there to help with the heat transfer. As soon as I put that iron down in there, it melted and heat transferred quickly. Let me flip it over. I mean, if you needed to, many times if you're using the right heat, you know, it's automatic. The backside will get flowed nicely. Also, if not, I would turn up the heat on my iron a little bit. Or if that's not an option, then you can always do both. You know, check the other side, see if it needs any reflow. It doesn't. It looks fine. If it did, again, I would come in here and wet a little bit. I'd bridge and then feed. So, you know, but yeah, it looks fine. So that was, you know, not necessary, but just to show you how you can reflow without any problem. And notice, you know, I'm not really poking at it. I'm holding the iron in there to actually get the heat to transfer. You don't want to be using your iron like a paintbrush. So I have 2 wires soldered, and I'll dress them in later. I'll just keep going. I'll solder the other 2 tabs. Maybe I'll try to show you how not to solder. I'll do the paintbrush technique, I call it, where you're like dabbing and poking at the workpiece. More like a painter than a solderer. I'll show you that, and I'll show you maybe what a cold joint looks like and so on. So let me get some wires stripped and clamped onto those terminals, and then we'll try to show some examples of bad soldering. Alright, so let's try to show you some examples of ways not to solder. For starters, looking at this soldering iron tip, and it's not really bright and shiny. It's been oxidizing while it sat in the stand. So I'm not going to come into my workpiece with a tip that looks like that. I'm going to clean it up. So through the brass sponge, maybe wet the tip a little bit, and come in nice and shiny. And again, like I mentioned before, on cheap irons like this, cheaper ones, that tip maintenance is a little tougher. So don't feel bad if you find that a little hard to manage a bright, shiny soldering iron tip. It is a little tougher with these. The heat setting helps with that. I did knock mine back. I told you a little less than 3/4. I'm about sitting at 2 o'clock position for the heat setting on this. So if you can see it there. And I like it. I like that. And that is how you set temperatures, even on the $250 soldering station, or $350 and whatever. You set temperature the same way, by operator feedback. There's not a magic number, because every workpiece varies, every soldering tip varies. So yes, they maintain a more accurate temperature. That does help you. But as far as picking the temperature, that's up to you. Whatever gets the job done in about 1 or 2 seconds, but and not excessive heat. So, all right, let's try some things that you maybe shouldn't do. We said don't paint like a painter, which means you would put paint on your paintbrush and then try to, come on. And I've seen this, you know, it's, you know, classic mistake. They're like, see, I got solder, I'm melting it, it's melted. All right, let me stick it on there, stick it on there. Let me get a little more on there. Sticking it on there. There you go. And it's kind of soldered, right? I mean, but maybe it could break easily. We would call that a cold joint. If you can rotate it a little bit. You see, I mean, obviously, this is an extreme case. It's jagged, it's lumpy, it didn't flow. You didn't bring the workpiece up to temperature. You did manage to stick some solder on it. But it's not really ideal, right? That could break off. It might not have bonded. Even if it did bond, it could break off later. So yeah. So we don't want that. Don't dab at it with the iron. Obviously, if we want to fix that, we would just come in, stay still with the iron, and flow. See how my iron's just staying still, bringing it up to temperature. Look at that. Obviously, that came up to temperature, and I was holding the iron perfectly still. That's why. And it came up fast. Well, I bridged it, and that heat transfer, if you don't understand the bridging concept, if you looked at it under a microscope, when you bring that iron tip against your workpiece, you're only contacting it at a few points because the surfaces aren't perfectly flat. So they're touching each other, but they look like two jagged edges where they just bump into each other at a couple points. When you flow that solder into bridge, you fill in all the gaps between the two rough surfaces. Air doesn't transfer heat very well compared to metal, so when you flow in that bridging solder, all of a sudden you have much more surface area contact between your iron and your workpiece. That's what causes the heat transfer to pick up rapidly. And that's what you want. You want to quickly transfer the heat. You don't want to be scorching points of your workpiece. You want to bridge, get that liquid solder in between your iron and your workpiece, and then don't leave it at that. Don't keep feeding where you bridged. Bridge to fill in the rough surfaces. They're microscopic rough surfaces, but they're there. But once you fill that in with liquid solder, the metal conducts the heat to the workpiece heats up, and your solder then is applied, out away from your iron. But look at that flow. It's a really good example of the opposite of dabbing. Look, it really flowed. Obviously, I brought that workpiece way up to temperature. And if I want more of a concave fillet, for strength, I can add a little more to that. It's fine the way it is, but if I wanted to see a little more strength here, I could flow in a little more right around that wire. Yep. And I'm pretty sure the backside kind of looked just fine because I really brought that thing up to temperature by laying it in there. Let's see how she looks on the backside. Yeah. So it's all flowed. Yep. If I wanted to close that in a little more, I could. All these things are just cosmetic at this point. That's a fine. It's fine as far as strength goes and reliability. Cosmetically, if I wanted to. I'm not saying you have to do this, but I could fill that in a little more because I didn't apply in on the backside. And actually, I can show you something here. If I felt like I had way too much solder, which can happen, let me just gob this thing up here. Okay, and it's hard to. This is such a large terminal that it's hard to even make it look like I gobbed it up. But if you have excess solder, you have something else. You have this side. You can see maybe I was busy on the back side, had no idea where all that solder was going. Well, it's pooling on the front here. So I got a lot on the front terminal that's it's not a problem in this case because these terminals are so large, but it could be a problem if you got carried away and too much runaway solder. That's what the solder braid is for, and you have some of this in your toolkit. It's just copper braid, and it just wicks solder into itself, and then I'll show you. You just heat it up. If I wanted to get rid of some of this solder, put the copper braid on there, heat the copper braid up. Takes a little while. Once the copper braid comes up to temperature, it'll soak that solder up like a sponge. This is one technique of desoldering. And again, it's sort of the poor man's way to desolder. So I got some of that solder off. If I had to get all the solder off, it'd be a little more work. I'd have to keep applying braid, This braid, you can see, soaked up that solder, and you just cut that off and throw it away. So it's, just chuck that. There are much nicer ways. Solder pumps, desoldering pumps, they're just a little vacuum. It's a hollow tip that heats up, and then the vacuum, you just squeeze the button and it sucks the solder right off the joint. So that's the nice way. So if you have a couple $100 to spend, you get that instead of this. You can also get the little hand pumps that just retract, or a little squeeze bulb or so on that sort of do that too. So you can suck the solder away, or you can wick it away with solder wick when you have excess solder. And sometimes you will need to do that. You might have put a part down on a PC board and it's in the wrong place. You put the wrong part there. So to desolder it, you can use the solder wick. It's the tougher way to do it. It's the cheap way, but it makes your work a little harder. But the solder pumps, we do have 2 of those in the labs that people can borrow. But yeah, the solder pumps make life real easy. Solder pumps are also more of a required tool, more than ever these days, because some of the through holes in a PC board, they are metal the whole way through. So that is tough to get that solder out of that through hole via using solder wick. You can be fighting a losing battle there. So sometimes the solder pumps are absolutely a necessity. That's the only way you're getting the solder out of that hole, if the hole is actually lined with metal. So, all right. On this last terminal, I tried to create like a balled up bit of solder to show a cold joint. It's kind of hard to do, I guess, because I don't know, I just had too much heat here, and so it kind of wicked out anyway. I was trying to show what it looks like, you know, if you were to have some kind of a cold fillet. It tends to be more like ball shaped than that volcano shape. So I guess maybe you can kind of see. But yeah, anytime you see something that's lumpy or balled up, you can tell it didn't get hot enough to flow, and it could break off later. It could be a bad connection. So I was trying to show that. But while I have solder on there, I can show you the other methods. Here we have an eyelet, and it's easy enough to put a wire through it and sort of squeeze it in place with a needle nose. But that tinning technique I was telling you about is also possible. There, I've actually applied solder to the terminal, and I'll take a piece of wire and apply solder to it separately, and that's called tinning. I can just use my my helping hand here, just to hold on to that wire for me. Now look, I can take this and I can just tin the wire, and what's happened is I've got good adhesion of solder to the wire and good adhesion to the terminal. We've got a little excess there. I'm going to nip that off. This is probably more of a technique you use when you might have like a real small terminal on a switch. Maybe you don't really have the option. It's too tiny to actually wrap wire around. You'll just bump into the next terminal and so on. So this works in some settings. It's the method of choice. But this would be tinning fusing, I call it, because I tin both pieces, and now all I'm going to do is just fuse them together. I don't even have to worry about applying solder. I can just hold the wire with my own hand and I can fuse them. See how that works? And that's that. And you could argue that there's not as much structural strength because you don't get that added mechanical strength. So I mean, yeah, it's nice to loop them through the eyelet if you have an eyelet, but that's, like I said, more if you don't have that option. If you have a real tiny workspace where you have to get a very tiny terminal and something soldered onto it. So, but that's it. Just to let you see another technique. You know. And again, if I wanted to remove it, because maybe I want to make all of them look the same, it's easy enough to clean this up and do it the way where I would feed it through the eyelet. How do I get all that excess solder off and get that eyelet exposed again? There we go. Get some solder braid on here. Soak up all that excess solder. That was a lot of excess solder because I was trying to show you the cold joint, but it wouldn't ball up because it had too much heat. Yeah. So anyway, just trying to get all that cleaned up. Okay. Oops. Got the solder braid stuck to the workpiece. Classic. Soldered the solder braid to the workpiece. Alright, so there we go. Fresh start. Using solder braid, cleaned it off, and I know, again, the solder braid is probably the most annoying way to do it. The $300 solder pump is the nice way to do it. Okay, so I'll just finish this up, and then I'll show you just dressing the wires in, and we'll be done. Last terminal, you have one more look at the soldering technique. Cleaned it off on the sponge, wetted it, bringing it in, fuse, bridging, getting that bridging. Come on, there you go. Okay, looks good. turns out on this one, I do actually want to touch up the backside just a little bit. The solder that flowed didn't really pick up this last little piece of wire that I had used to help crimp it, in place. So let me just get the flow to show you there. I wanted to reflow that. There we go. Just wanted to include that bit of bare wire so it doesn't just float around there. One thing you will notice is the bits of burnt flux. Flux is inside in this solder, in rosin core solder. There's a flux, a cleaning agent inside the solder, and that's that bit of amber color, and then that black burnt color is a burnt rosin flux. So flux remover will clean that up for you. So that's usually the final step. Get that off of there so it doesn't keep corroding things, or just looks nicer too. But yeah, flux remover, it's a solvent that'll just take that right off. So that'd be the final step to cleaning up those solder joints. Okay, so we've got our 4 wires soldered on. They're all just running wild with more than enough length at this point. And now it's just a matter of cutting them to length, stripping them, dressing them in nice and neat. You can do that even as a first step if you want to do it all at once. Sometimes that's a little less nerve-wracking, because now, of course, I'm a little nervous because I have everything soldered nicely, and if I cut something too short, I'm going to be a little upset because I got to get that solder braid out, desolder, get a new wire and everything. So it's true. Sometimes you might want to dress it all in and save the soldering for last. That'd be maybe a smart move. These wires, they are solid. It's 22 gauge and they're solid. We did that so that they'll make a nice insert into the breadboard. But solid wire has a big drawback, and that is it can only be bent so many times before it just breaks. So we want to be careful not to overdo things. As we're dressing them in, we just don't want to be wiggling it back and forth, bending it too many times. You've only got so many times you can bend solid wire before it just breaks. And sometimes the break is internal, so you might not even know that you really compromised it. So I'm going to be careful. I'm not going to be too crazy, pushing things. I just want to make sure I get a couple efficient moves here and bend it where I want it. So I like this blue one that I'm dressing in. See how I kind of pick that, down in the channel and over, and then I got to figure out what length. So this battery I'm going to bring up to these 2 buses. Now I know I need about a 1/4 inch length, right? So I'm gonna aim for that first hole right there. So I'm going to need to go past that enough, and that looks pretty good. And this is, like I say, if you want to do this as a first step, that way if you're new to it, you might worry, you're going to get it right, and you'd have to unsolder wires if you get it wrong. So yeah, I'm going to do that. Now I'm going to just use our wire strippers. The ones that we have in your toolbox, that's the only ones we have available from that supplier, but you can go on Amazon. These are a nice wire stripper because you can set the strip length right here. There's a little stop here you can slide around, and you know what length you need for your breadboard. They also are just nice when you have really short wires to deal with. You can just get in there and they just draw back. So sort of an automatic stripping action. For breadboarding, these are great. I wish the company Electronics Express, I wish they had these. They don't. But I got these off of Amazon for like $10. And when you're trying just to do little bit of wire stripping, for breadboarding, they're hard to beat. So here we go, and let's see if I can hit the spot that I was looking for. So there it is. All dressed in, nice and pretty. That's what we want. And it's not just for the aesthetics. It's not just because it looks nice. It's because it won't get knocked out of place. It's reliability that we're looking for too, not just looks. Although they often go hand in hand, don't they? I mean, If something looks beautiful, there's a reason, because we know it also is probably, probably going to work. It's going to be done right, and so on. So we can recognize it when we see it. But yeah, so it'll stay out of the way if we keep the wire dressed in down here. It's not going to get knocked out because this isn't soldered or anything. So that's just pressed in place, and we don't want to have to worry about it coming loose. And for the red wire, I'm not going to aim for this insert point. I could aim here, but I'm even going to give myself a little more distance. And the reason is, if they do have a little bare wire sticking up, because sometimes that happens, you don't have the insulation all the way down in there. But why risk the two bumping together? So again, just giving myself a little distance. And the reason I can also do that is it's not, real estate isn't really that hard to come by here. I mean, I have this whole bus here to use as a connection points. So I mean, if space was a little tighter, I'd probably put the red wire right there. I do for myself. I don't, as a practice, I tend to give myself at least that much space away. I don't usually put them right next to each other. Again, for the reasons of if they come a little loose or one starts to pop out a little, and then you have the bare wire, and the bare wires are right next to each other. Just don't want them bumping together and shorting out the power supply. So I'm going to aim for, I'm going to aim right here, which means I should cut it right about there, right? So, give yourself that insertion length, right? And here again, whoops, let's see if I can do this a little awkward. Okay, so there we go. Again, these super nice wire strippers. See how convenient that is. Whoops, still hard to grab. Okay, let's see here. Okay, spin that around. Yeah, since you don't have these wire strippers, that might be another reason. I'm looking at this and I'm thinking, probably you do want to maybe strip wires first, huh? And you might be having a tough time with the other type of hand strippers. I'm going to try to find a way to make this wire reliable. I guess that works for me, something like that. Again, you don't want to go crazy bending back and forth, trying too many different things, or the wire can break. It is solid wire. And so here we have them all dressed in now. Like I said, feel free to do this as a first step in case something doesn't go well. Maybe it's easier to start over if you don't already have the soldering done. You can see a good example of why I like to keep some distance between the two. I'll move this up a little bit. See my one red wire here? There's when I pressed it in, I saw that I have the insulation stripped back a little bit extra. So I don't like that. I don't like that metal, that bare metal, to be too close, in case the other one also turns out like that. So that's why I kind of get in the habit of spacing them out a little bit. Then I don't have to worry about that if it comes up a little bit looking like that. I'm not worried about the two bumping into each other. Then you can just put the batteries in, and you can leave the batteries in as long as you're sure you don't have some circuit hooked up. Like later when we'll be doing simple circuits, you don't want to drain your batteries accidentally. Put the batteries in. Maybe it's not a bad idea to just put them in there and make sure they're not heating up. I mean, if they're heating up, you've got something shorted out, like maybe these tabs bumping into the frame, two tabs together. So it'll get hot quickly if you have an accidental short. So just make sure that that's all good. And then if the batteries are staying cool, they're fine. They can stay just like that and store them right in there. Yeah, little AA batteries, they can make great hand warmers. You just short them out and you'll have warm hands in no time. Final inspection is probably just making sure that all the tabs are far enough away. All the tabs here are far enough away from the battery holder itself. So I mean, you want to make sure you have clearance there, right, everywhere. See that? I mean, you could even, if you prefer, I mean, you could take this wire and bring it in from the outside of that eyelet, whatever your preference is, you know. Maybe that would have looked a little better, who knows. But do make sure you have clearance everywhere between those eyelets and the bare wire. Nothing should be too close to bumping into the terminal, the battery holder itself. If you feel like there's not enough clearance there, like down in there, you can flare those out a little more. You just have to be confident that no wire is going to be bumping into that. So I mean, I could even push this wire out a little bit, right? I could flare this out a little bit. Yeah, I mean, because that's one point that we do see. You know, that's an easy place to have a problem. It's all bare metal here, so you got to make sure you got those clearances. Like I say, flare those out, but give a good inspection there, good visual. Make sure nothing's touching. And you know, I like this one the best. You know, this one has obvious clearance. Some of the other ones are a little tight, so I might flare those out a little bit. And like I said, if you even prefer bringing the wiring from the back side, that brings the insulation over here. I think I might have done that other years, so maybe that's a better choice. Okay.